everyone. Today I will take you through this Jupyter notebook. In this project we have done on the Board Game Geek reviews. It's one of the Kaggle competition, and you'll be able to find the link to the competition in this Jupyter notebook. This Jupyter notebook has four main sections. We will go through them. We're not going to skip other parts, but let's start with the part that's related to the data. In these three sections, you're going to learn how to download the data, clean the data set, and prepare them to be able to fit in the machine learning method. So let's come here and look about what's our targeted and what's our feature we're going to use to train the machine learning method. And before that, let's remember our goal for this project is predict the rating based on a given reviews. For example, if the reviews is someone very exciting about the game and has very comment about the game, it should have a better rating. And otherwise, it's gonna get a low rating. So let's come here to this part. First of all, look at about our data. It's very crucial that you go and download the data in your local machine. And if you go through the README file, you're going to learn how to download Jupyter Notebook in your machine and how you can run it in the local host. You come here to this part, you have to put the right path or the right directory for your files in your own machine. So here, just a quick look on the data frame. You can see this one has a lot of features, but not all of them are important. And for the second file, the first one was talking about the game details. The second one, game details, sorry. The second one's about the reviews, and the last one is for the rating. Here you can look actually also to the second file and the third file. If you go to the Kaggle website, you're going to learn more about this feature, but it's not our main focus for this tutorial. Let's go ahead and look for our targeted and training features. So we only focused on the comments, the text, and the reviews we need to analyze and be able to predict the rating, which is our target. An important step we have to do here is splitting the data set X and Y into training set and testing set. The training set will be used to train the model, and the test set will be used to evaluate the model generalization with unlabeled target. The next important thing is how we prepare the text and be able to use it to fit it in the machine learning method. There's two ways or more than that from sklearn machine. Here we apply the count vectorizer and the TF-ID vectorizer. If you read this text, you will be able to learn more about this. Mainly, this one gives us a better performance. It's taking all the words from the text or the reviews and transfer them in a matrix representation with the frequency for each term or words in the text. So we are here. The third main thing is the model selection. We applied many machine learning methods. You can see some of them here to be able to figure out which machine learning method is more suitable for our problem. And actually, there is no way to know which one is always going to give you the better performance. It's usually based on practice and testing. But in the same time, there are some methods known that it works well for the text and others are not, because for the matrix you will have a lot of sparse matrix, which is mean, yeah. So if you go through all of these, you're going to learn more about them. And now we are here in this step where we be able to fit and predict our model. So we define the classifier having all those machine learning methods in only one array, and through the iteration, the system is going to take them one by one and fit the training data into the model, then predict the training set, the test set. And here we have some representation and graphs show you how the predictor behave. Down there, the blue one is the actual data, and the orange one is the predictor. We can see there are some differences between them, and there's so many metrics we can use to check on the error. For example, for just this logistic regression, we have the training score about 87, but the test score is very low. It's just about 20%, which means there's a lot of room to improve the model by using other techniques or other methods. So you can just go through this part. Then, from our work, we find that the best model is the random forest classifier with 94% accuracy on the training set, but still it's only 22% on the test set. At the same time, these numbers show us that our model is suffering from overfitting. Another model we can look at is the decision tree classifier. We can see here what's the difference between the actual and the predicting values. And for this model, we can see that the 94% is accuracy on the training and only 18% on the testing, which is still very low. And in the same time, we know that this method is suffering from overfitting. Overfitting means our model is very complex and needs more optimization. There's a lot of optimization techniques we can use to overcome or try to ease this problem. And finally, for the last step, after we evaluated different machine learning methods and then we select the most promising one, we can do what's called hyperparameter tuning and model optimization. Some of the algorithms for that cross-validation, and also there is what is called grid search. And finally, for the random forest, because we use random forest, there is the randomized search cross-validation. So here, what we really want to do is hyperparameter tuning, which means we play with the parameters for the machine learning method, and in our case, it's the random forest, and change those parameters until we get the better performance. For the random forest classifier, these are the parameters we can keep changing till we have the testing. But using this algorithm will help you a lot, because automatically it's going to try to figure out which set of parameters is the best parameters. And you can see from here is giving you that the number of estimator and the minimum samples built, and the maximum number of features, and so on. For this problem, our final accuracy was 69%, which is not very good, but this is what we get for this work. So hope you go through this file and understand and learn better from it. And please, you can contact if you have any questions. Thank you very much. Have a good day.